This is section 7.1, areas of rectangles, parallelograms, and triangles. The area of a region is the number of square units needed to cover it completely. Think of wrapping something. It's how much wrapping paper you would need to cover it. It's always in square units, meaning the label is always going to be whatever the units are squared. So starting with a square, the most simple one we have, the area of a square is equal to the length of the side squared, which means if you wanted to solve for the side of the square given the area, you could say the side of the square is the square root of the area. So let's look at an example. If this is our square and each side is 4 units long, we could say the area would be 4 squared, which is 16. Most of the time they'll give you whether it's inches or meters. Make sure you always have your label and make sure your units are always squared. The area addition postulate says if the interiors of two regions do not intersect, meaning there's no sort of overlap between them, then the area of their union is the, this is supposed to be sum of the areas. So let's look at an example. If I was given this figure, okay, and it says that this is 9, 10, 5, 7, and 2. I could break this into its sections that don't overlap, and then I could add the areas. I could say it's going to be this rectangle plus this rectangle plus this rectangle. As long as the areas don't overlap, I can add them together. So I can see the one in red is 9 by 5. I could see the one in blue, well, the top part would be 10 minus 5 because I'm not including this piece, which is 5. This length here would be 9 minus 7 because I'm not including this part, which is 2. So in blue I would have 5 times 2. And then in the green I would see I have 2 times, this would also be 7. So I could find each of their areas and I could add them together. Maybe you saw it a little bit differently and you broke up your figure differently. The idea is if they don't intersect, you can add the shapes together. Now I could have also figured out maybe the area of the shape as a whole, which looks like it's 9 by 10. And I could subtract that piece in the middle if I wanted to as well. So you can either add or subtract if they do overlap. It's up to you, whatever you see more clearly. Congruent regions postulate. The congruent regions postulate says that if you have congruent figures, so let's say we have 2 squares that are the exact same size and shape. Well, if they have the exact same size and shape, they will have the same area. So if the length of all of these sides is 40, I know when I solve for the area by plugging it in, 40 times 40 is going to be the same as 40 times 40. Our next shape we have is a rectangle. The area of the rectangle is the base of the rectangle times the height of the rectangle. We know that in a rectangle, we do not have all four sides congruent, but we have opposite sides congruent. So in that case, one would be our base and the other would be the height. It's similar to the formula for a square, except for the square, the base and the height are the exact same size, so we can abbreviate to the s squared formula instead. Now, area of a parallelogram is the same formula as a rectangle, but we might see something a little bit different. Parallelograms don't always have right angles, but our height always needs to be connected to a right angle. The base doesn't necessarily mean that it's the bottom of the shape. I could have a figure that looks like this, where this is my height and this is my base. I could also be given a figure that looks like this, where this is my height and this is my base. So base doesn't mean bottom. The base and the height will always be connected by the right angle. So if we were given this picture, it says that this is 13 feet, 25 feet, and this is 10 feet. Well, I know my base and my height are always connected by the right angle. Because it's a parallelogram, opposite sides are congruent. This is going to be 13 and this is going to be 25. I'm not concerned with the side that's 13 because it has nothing to do with the right angle. So my base would be 25 and my height is 10 for an area of 250 feet squared. Lastly, we have the area of a triangle. Area of a triangle is 1/2 the base times the height. Again, the base doesn't necessarily mean it's the bottom number. The height and the base will always be connected with a right angle. So if this is our triangle, none of these are right angles, but I can see this altitude is drawn. Let's say they give us this is h, and they say the area is 54 feet squared. So I can use my formula, plug in 54 for the A, 12 for the base, and h for the height, and I can solve for my height. So I get that my height is 9 feet. Again, don't forget your label. Since we're talking about height and not an area, my units are by themselves, they are not squared. Alright, so now you have time to work on the 7.1 assignment that is due tomorrow in class. Thanks.